Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET JEE-Main, we're going to be looking at previous year questions of physics asked in medical and engineering entrance exams in India. Today we're dealing with a very important chapter. The name of this chapter is Current Electricity. Now this chapter deals with moving charges in a conductor, which we call current. So this is the third chapter in the grade 12 syllabus for physics in CBSE. This chapter is very important and we have made some episodes on this chapter before. So here's another episode with more questions. Here lies the first question. In a potentiometer experiment of a cell of EMF 1.25 volts, it gives a balancing length of 30 centimeters. If the cell is replaced by another cell, balancing length is found to be 40 centimeters. You need to find the EMF of the second cell. So, what are the quantities that are given in this question? So, a cell of EMF 1.25 volts gives a balancing length of 30 centimeters. So that means E1 equals 1.25 volts and L1, that is the balancing length, is equal to 30 centimeters. Now if the cell is replaced by another cell, the balancing length is 40, so that means L2 equals 40 centimeters. The trouble is they haven't given us the value of E2, so we need to find out the EMF of the second cell. How do we find out this quantity? We use the ratio of EMFs in a potentiometer. So in a balanced condition, E1 divided by E2, that's the ratio between the two EMFs, is equal to L1 divided by L2, the ratio of the balancing lengths of the two EMFs. So since E1 by E2 equals L1 by L2, all we have to do is substitute values. E1 is 1.25 volts divided by E2 gives 30 centimeters divided by 40 centimeters. So now what we're going to do is we're going to take E2 to the numerator on the other side. So we'll take E2 on one side, and then L2, and the other side, the right hand side, will now be equal to 1.25 divided by 3 by 4. So basically that's 30 by 40. You cut the zeros out, it becomes 3 by 4. Now 3 by 4 is 0.75. So we'll just put in that value. Now we multiply both the numerator and denominator by 100. So you get 125 divided by 75. Now notice that both 75 and 125 are the multiples of 25. So 25 times 5 gives you 125, and 25 times 3 gives you 75. So the value of EMF is equal to 5 divided by 3. So when you divide 5 by 3, there's 1 minus 3, so that gives you 2. And then there's a point, and then there's a 0, so that is 20. So 3 goes into 26 times, and if you subtract 18 from it, you'll get 2 again. So it becomes 1.66666, and the decimals go on. So the approximate value of the EMF here is equal to 1.67 volts. So the value of EMF E2, which has a balancing length of 40 centimeters, is equal to 1.67 volts. And among the options, it is clear that option D is the correct answer for this question asked in 2018. Let's look at the next question. In the circuit shown, the current passing through the 5 ohm resistor is it 8 by 3 amps, 9 by 3 amps, 4 by 3 amps, 9 by 13, 4 by 13, or 1 by 3 amperes? So how do we solve this question? Well, in order to solve this question, let's name the corners here. So you have A, you have B, you have C, you have D for the main square circuit with both the resistors of 2 ohms and both the EMFs. Next, we have E and then F. So, and then there's G, and then there's H. So now what we're going to do is we're going to apply Kirchhoff's second law, which we normally refer to as the loop rule. So what does this loop rule states? It states that the decrement in EMF across an entire closed loop of circuits is equal to 0. So for example, if you go from point A and then you go down E and then F and then G and then H and then B and then back to A, then what we know according to this law is that the total change in EMF is 0. So whatever decrement of EMF the circuit is being given, they all are equal. So the sum of all the decrement of the EMF in a closed circuit, that is equal to 0. So now let's apply that here. So first loop in this case is A, E, F, G, H, B, A. So over here, what we need to find out is the value of the current and the resistance here. So let's take current passing through AB as I1, and let's take current passing through DC as I2. So that means through the circuit EFGH, the current that is flowing is I1 plus I2. So that makes the current part. The resistances are already given. So now, as you can see, when you take the loop A, E, F, G, H, B, A, the current that is I1 plus I2 is first passing through a 5 ohm resistor. So when current is passing through a resistance, some EMF is lost. So we have a decrement in voltage. So therefore, in loop A, E, F, G, H, B, A, you will have minus of I1 plus I2 times the resistance, that is 5 ohms. Next, when we go along the loop, we go to the arm BA, and in the arm BA you also have a 2 ohm resistor, and we have the current I1, so we need to subtract 2 times I1. And then since from the negative part of the battery we're moving to the positive part of the battery, there is an increase in voltage by 2 volts. So plus 2V equals 0. So on calculating further, you get minus 5I1 minus 5I2 minus 2I1 plus 2 volts. So minus 7I1 minus 5I2 plus 2 equals 0. That means you will get 7I1 plus 5I2 as equal to 2. This is equation 1. Let's mark this as equation 1. Now let's look at the next arm, which is the current passing through the loop D, E, F, G, H, C, D. So in loop D, E, F, G, H, C, D. So through this loop, you can see that first of all, there's the current I1 plus I2 passing through the 5 ohm resistor. So therefore, that means you have a negative of I1 plus I2 times 5. Then we have the current I2, which is passing only through CD. And then through CD, it passes through a 2 ohm resistor. So therefore that means minus 2 times I2. Then you have an increment of 2 volts because the voltage is being stepped up from negative to positive terminal. So therefore plus 2. That is equal to 0. So therefore minus 5i1 minus 5i2 minus 2i2 plus 2 equals 0. So therefore you have minus 5i1 minus 7i2 plus 2 gives you 0. So therefore 5i1 plus 7i2 will be equal to 2. Will be equal to 2. So therefore we can take this equation as equation number 2. So now we have two equations, 1 and 2. We just need to find out the value of the current passing through the 5 ohm resistor, which in this case is I1 plus I2. So we have 7i1 plus 5i2 equals 2. And then you have 5i1 plus 7i2 equals 2. So what are we going to do here? We just need to eliminate one of these variables. So we'll get an equation in one variable, and then we'll find out the answer to one of the variables, apply that to one of these two equations so as to get the second variable. So we have 7 and 5, and we know that 7 times 5 equals 35. So for similarity's sake, let's cancel out I2. So for that, we need to multiply by 7 in equation 1 and multiply by 5 in equation 2. 7 times 7 is 49, I1, plus 7 times 5 is 35, I2, equals 2 times 7 is 14. Then you have 5 times 5 is 25, I1, plus 5 times 7 is 35, I2, equals 2 times 5, that is 10. So we have to subtract 7 times equation 1 and from 5 times equation 2. So 49 minus 25, now that will be equal to, when you do the calculation, 49 minus 25, 9 minus 5 gives you 4, 4 minus 2 gives you 2. So you have 24i1, 35 and 35 cancel each other out, so that's 0, and 14 minus 10 gives you 4. So 24i1 is equal to 4, so therefore I1 equals 4 divided by 24. 4 goes into 24 6 times, so therefore I1 equals 1 by 6. So we know the value of I1. Now let's apply the value of I1 in equation 1. So 7 times 1 by 6 plus 5 times I2 equals 2. So 5i2 equals 2 minus 7 by 6. So that is, 12 minus 7 by 6. So that is 5 by 6. Therefore, I2 will be equal to 5 by 6 into 5 by 6 divided by 5. So that is 5 by 6 into 5. So therefore, you get 1 by 6 again. So I1 is 1 by 6, I2 is 1 by 6. So the current passing through the 5 ohm resistor is I1 plus I2, which is 1 by 6 plus 1 by 6. That gives you 2 by 6, which is equal to 1 by 3 amperes. So the correct answer is 1 by 3 amperes, which if we look at our options, we can find out that option D is the correct answer for this question asked in 2018. Now, we have another circuit here. This is the next question. The measurement of voltmeter in the following circuit is. So we need to find out the measurement of voltage through a voltmeter of resistance 40 ohms. So how do we solve this question? So as you can see here, the voltmeter of 40 ohms and the resistance of 60 ohms are in parallel. So first we need to find out the total resistance of the circuit. 1 by RVR, that gives you 1 by 60 plus 1 by 40. So therefore, RVR gives you 60 times 40 divided by 60 plus 40. So therefore, 60 plus 40 is 100, and 60 times 40 is 2400. So the resistance across this parallel connection here is 24 ohms. So our equivalent, that's the total resistance, is 40 ohms plus 24 ohms, which is equal to 64 ohms. So now we know the total resistance of the circuit, that is 64 ohms. Next, we need to find the current passing through the circuit, the total current passing through. So over here, I total is equal to the voltage found on the battery divided by the total resistance. So in this case, that is 6 divided by 64, which is 3 by 32 amperes. So the current passing through the circuit is totally equal to 3 by 32 amperes. Now, when we look at the voltmeter here, you can see that the voltmeter is connected in parallel to the 60 ohm circuit, to the 60 ohm resistor. And in any circuit, we connect the voltmeter parallel to the voltage, parallel to the resistor, across which we need to find the voltage. So basically, since voltmeter is connected across the 60 ohm resistor of the circuit, we need then the reading of the voltmeter, that will be equal to the potential difference across the 60 ohm resistor, which in this case is I times R, that is 60, so 3 by 32 into 60. I mean, actually, since here we have a parallel connection, so it's across the 60 ohm resistor, but since the voltmeter also has a 40 ohm resistor in parallel, the total resistance here is RVR. So I, that is 3 by 32, is multiplied with RVR, which is 24 ohms, in order to get the reading of the voltmeter. So 24 and 32 are multiples of 8. 32 goes into 8 4 times. 24 goes into 8 3 times. So you have 9 by 4. So the reading of the voltmeter V is equal to 2.25 volts. So 2.25 volts is the correct answer for this question, which was asked in 2017. The main idea here is to find the total resistance of the circuit and find the total current, and then we need to find out the amount of current that is passing across the parallel connection here. Now, the reason why we take the whole parallel connection is because, you know, voltage is same across the 60 ohm and the 40 ohm resistor, so therefore the voltmeter reading will show the value of the voltage when it's across this parallel combination, which has a total resistance of 24 ohms. So option A, 2.25 volts, is the correct answer. Next question. This question is based up on the meter bridge. A meter bridge is set up as shown to determine an unknown resistance X using a standard 10 ohm resistor. The galvanometer shows null point when tapping key is at 52 centimeter mark. The end corrections are 1 centimeter and 2 centimeter respectively for the ends A and B. The determined value of X is it 10.2 ohms? Is it 10.6 ohms? Is it 10.8 ohms? Or is it 11.1 ohms? How do we solve this question? Let's find out. First, we need to identify what are the quantities given to us. Now, the unknown resistor X is the one we need to find out. We know that the resistance R is a standard 10 ohm resistor, so R equals 10 ohms. The galvanometer here shows the null point when tapping key is at 52 centimeter mark. But remember that we also have end corrections on this meter bridge wire, so therefore L observed is equal to 52 centimeters, and 100 minus L, which is again observed, is equal to 100 minus 52, that is 48 centimeter. So 10 minus 2 is 8, 9 minus 5 is 4. 48 centimeters. Next, it's given that the end correction for end A is 1 centimeter and the end correction for end B is 2 centimeters. So what does that mean? The quantity that is the balancing length, L, is measured from end A. So if the end A has an end correction of 1 centimeters, then the corrected value of L will be 52 plus 1, that is 53 ohms. Similarly, 100 minus L is calculated from end B. So therefore, if end B has an end correction of 2 centimeters, then the corrected value of 100 minus L is 48 plus 2, which is equal to 50 ohms. So now we know the corrected values of L and 100 minus L. What we can do is we can apply the balance condition of the Wheatstone bridge. So according to balanced condition of the Wheatstone bridge, we can write X by R as equal to L divided by 100 minus L. The meter bridge is basically a simplified version of a Wheatstone bridge, where you have 4 resistors. You have X, that's the unknown resistor. You have R, that's the standard resistor. You have the resistance passing through the resistance of the wires at L and 100 minus L respectively. So therefore, those are the 4 resistances in this Wheatstone bridge circuit. And when the galvanometer shows 0, we know that it's a balanced condition. So in the balanced condition, X by R equals L by 100 minus L. Let's apply the values. X divided by 10 gives you 53 divided by 50. So therefore, you'll get X equals 53 times 10 divided by 50. So 10 goes into 55 times. So you have 53 divided by 5 as the value of X. So you have 1 minus 5 gives you 0. Then there's 3. So since 5 does not go into 3, you add a 0. You put in a 0, and then when you put a point, you get an extra 0, so that's 30. So 5 goes into 36 times, so minus 30 gives you 0. So the value of X, that is the unknown resistance, is 10.6 ohms. And we found this quantity by using the balance condition of the Wheatstone bridge, wherein X by R equals L divided by 100 minus L. Now this formula that we just wrote is specific for a meter bridge. The original formula is just P by Q equals R by S, where P, Q, R, S are the 4 resistances in a Wheatstone bridge. Now here, since some of those values are based on the length, the balancing length, so therefore the specific formula for meter bridge goes like this: X by R equals L by 100 minus L. So the value of X is 10.6 ohms. We calculated that as the correct answer. And so therefore, if you look at the following options, you can see that option B is the correct answer to this question, the correct option to this question asked in 2017. Now, let's look at the final question of this episode. On increasing the temperature of a conductor, its resistance increases because A, the relaxation time increases, B, the electron density decreases, C, the relaxation time decreases. D, the relaxation time remains constant. So how do we solve this question? Well, to solve this question, it's a good idea to write down the formula for resistance. So resistance can be written down as rho L divided by A, where rho is the resistivity. And this same resistivity can be written down as M divided by N E squared times tau, where M is the mass, N is the number of electrons, E stands for electron density, which is constant, and tau stands for relaxation time of the electrons. So now we will apply the value of rho here. So R equals ml divided by N E squared tau times A. So now what we can do is we can derive the relation R is inversely proportional to the relaxation time. So if the resistance increases, it is because the relaxation time is being decreased. So we've already found our answer. But how do we know if resistance increases if the temperature increases? Well, for that we use the formula R equals R naught times 1 plus alpha T, where the capital T stands for temperature in Kelvin, so R is proportional to T. So as temperature increases, the resistance increases. So as resistance increases, according to our earlier formula, the relaxation time of electrons decreases. So therefore, option C, relaxation time decreases, is the correct option for this question. So for this question asked in 2015, the correct answer is option C, relaxation time decreases. So that concludes this episode of NEET preparation. So we hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel. That is Brain Blitz Audios. We have a lot of videos on, various chapters in physics as well as chemistry and biology for NEET and mathematics for JEE. So if you want to access our useful content, then don't forget to hit the links given in the description box down below. You can also hit the notifications button to receive our latest content so that you do not miss out on anything. So until the next webisode, take care, stay safe, bye-bye for now.